of life, time and time again. Near-Earth objects are asteroids and comets whose orbits bring them close to Earth's orbit. In the case of asteroids, Jupiter's gravity or light pressure from the Sun can bump these cosmic relics out of the asteroid belt. Similarly, the gravity from planet Neptune can nudge comets out of the Kuiper belt. The scars from asteroid impacts can be seen throughout our solar system. All the terrestrial planets and moons show the marks of these deadly blows, including Earth. 65 million years ago, a cosmic object, roughly 6 miles across, impacted the Yucatan Peninsula near the modern village of Chicxulub, Mexico. It produced kinetic energy equivalent to 8 billion Hiroshima atomic bombs. The impact event left a crater in the ocean over 110 miles across and 20 times as deep as the Grand Canyon.
Because the impact event hit the sea simultaneously, this created tsunami-sized ripples that then crashed onto the shoreline of the Gulf of Mexico. The energy and the explosive ejection of that material from the crater was so dramatic that that molten debris actually blanketed all of North America. Life as we know it would have been virtually erased.
Many scientists now believe the impact event extinguished 75% of animal and plant species on land and sea, including the dinosaurs. Planetary geologist David Kring is one of the foremost experts on asteroid impact events.
We now understand that impact events aren't simply a geologic process that excavates a bowl-shaped cavity, but one that actually can affect the environment, whether it be local, regional, or global.
In 2001, Kring headed up the Chicxulub Scientific Drilling Project near the impact site in the Yucatan Peninsula. Kring's goal was to find evidence that the Chicxulub impact produced worldwide climate effects by drilling down to the rock dating to that time period.
The drilling project confirmed our suspicions that the impact event had collided with a series of very important rock types, limestone and anhydrite. The limestone, when vaporized, produced greenhouse-warming carbon dioxide, and the anhydrite, when vaporized, produced sulfuric acid rain. And so this confirmed some of the global climatic effects produced by the Chicxulub impact event.
The Chicxulub Scientific Drilling Project also revealed that the impact generated hydrothermal systems that span the entire diameter of the crater. These processes provided critical environments for new life to evolve.
The extinction of the dinosaurs and the other life that disappeared 65 million years ago created new environmental and ecological niches. So the survivors were able to evolve and take hold of those new opportunities. The subsequent evolution has led to the formation or the evolution of our own species, the human species.
The next Chicxulub-sized impact is estimated to occur 35 million years from now. But one can never be too certain when it comes to space rocks.
Unfortunately, these types of things do not occur like clockwork. In fact, the next Chicxulub-size impact event could occur tomorrow.
Many scientists are confident that a cosmic impact was responsible for wiping out the dinosaur. But they're still debating about what type of rock.
We aren't actually sure whether this was an impacting asteroid or an impacting comet, although the bulk of the evidence points towards an asteroid. Asteroids, in fact, dominate the flux of impacting debris to the Earth. Somewhere on the order of 85 to 95% of the objects that collide with the Earth come from the main asteroid belt.
If we do find a comet on an Earth-threatening trajectory, it could be difficult to deflect or destroy before it inflicts apocalyptic destruction. Near-Earth objects are asteroids that have been dislodged from the asteroid belt into Earth-crossing orbits and therefore could again one day strike our planet. Although most potentially hazardous objects are asteroids, comets remain a legitimate threat. These icy bodies, which come from the outer solar system, can travel 3 times faster than asteroids, so it only takes 9 months for them to get from the orbit of Jupiter to the orbit of Earth.
You couldn't plan years ahead for an impact from most comets. You'd hear about it maybe a few weeks ahead, maybe months at the most.
Fortunately, Jupiter acts as a planetary shield. It deflects or absorbs comets that drift towards Earth. And scientists now have the pictures to prove it. On July 22, 1994, telescopes around the world caught a glimpse of one of the most violent comet impacts in the history of humanity. A string of about 20 comet fragments named Shoemaker-Levy 9 crashed into the upper cloud decks of Jupiter at speeds 100 times faster than a speeding bullet. Since gaseous Jupiter doesn't have a solid surface, the objects were slowed down by its thick atmosphere and exploded as air bursts, which created plumes that were visible from Earth. At Sandia National Laboratories in Albuquerque, New Mexico, physicist Mark Boslow and his colleagues had predetermined that this cosmic spectacle would be seen from Earth through computer simulations.
People really did not expect this to be observable, partly because the location of the impacts were actually over the horizon, over the limb of Jupiter as viewed from the Earth. We simulated the interaction of the fragments with Jupiter's atmosphere at high velocity and the giant plume that was ejected out into space and could be seen rising over Jupiter's horizon as viewed from the Earth and from the Hubble Space Telescope.
Armed with new knowledge about airburst impacts, Boslow began reinvestigating a similar event that happened on our planet. On June 30th, 1908, the biggest cosmic disaster in recorded human history on Earth occurred in Russia. A large object exploded in Siberia's remote Tunguska wilderness. The blast ignited heat and shock waves, which toppled 80 million trees over an 800 square mile area. Yet no one was directly killed because few people lived in the area. The Tunguska disaster had baffled scientists for almost a century because no impact crater or meteorite has been found, and many of the trees in the area were flattened but not incinerated. Many scientists finally came to the conclusion that a space rock exploded as an airburst when it hit our atmosphere.
So this was an atmospheric explosion.